Hello people, today we'll be solving LeetCode daily question 343, which is integer break, and then we'll be moving to the step-by-step Java solution for it. So the problem we are tackling today is about breaking an integer into the sum of positive integers to maximize their product, and we'll be given an integer n, and we need to break it into k positive integers where k should be greater than or equal to 2. Our goal is to find the maximum possible product which we can obtain from these k positive integers. So let's move to the whiteboard. For the question states that, for example, if we are given uh, and say 10, okay, so we can form 10 let me increase the text size. Yeah, so for example, if we are given 10, we'll have to break this into at least k positive integer. Let's say 1 comma 9. Okay, the text is a little too big. Okay, yeah, let's say 1 comma 9 is one possible solution. Other possible solution could be 2 comma 8. Other possible solution could be 4 comma 6, or let's say we can also have 2 comma 2 comma 6, and we can also have 3 comma 3 comma 4. Other than this, 3 comma 3 comma 2 comma 2, and another one we could have, let's say 7 comma 3, and we could have n possible solution. So our goal is to find the maximum product which we can generate by breaking this integer n, let's call it n, into at least k positive integers, into at least 2 positive integers. So for example, if we try to calculate the product of 1 and 9, this will give us 9. Let's say for 2 and 8, it will be giving me 16. But similarly for 4, it will be giving me 24. And if I see for 2 comma 2 comma 2 into 2 into 6, 2 into 2 is 4, 4 into 6 is 24. If I see for 3 into 3 into 4, I'll be getting 36. 3 into 3 9, 9 into 4 36. If I see for 3 3 2 2, oh, I'll be getting the same result, that is 36. And if I check for 7 into 3, I'll be getting 21. And we can generate n possible solutions, but the answer would be this 36, as it is already given in the test case. We can see here. Okay, yeah, we can see here. This would be our output. Okay, so let's move to the approach, like how we have to approach this question. Okay, and also apart from this, we can also have one more observation. Like if we are having a number, let's say n, which is less than or equal to 3. Let me increase the font size. Yeah, okay, let's say we are having a number, let's say 1. For example, for 1 we only have one possible solution to make this. For 1 we have 0 possible solutions, because for at least making 1 we'll need 0 and 1, at least 2 positive integers. These both are will be required, and this will give us the maximum product as 0. For making 2, the answer should be 1. At least I'll be there are only 2 ways to form the sum of 2, which is 1 comma 1. And other than this, I can use 0 comma 2. But 0 comma 2 will give me a result of 0. so we'll not use that. If I go for 3, I can form 3. The maximum output which I can get would be 2. The maximum product which I can get would be 2 by using 1 and 2. If I try to use others for, let's say, 1 comma 1 comma 1, this will be yielding me output as 1. So if I do this from here, it will be yielding me output as 0, and it will be yielding me output as 1. And if I go for, yeah, only these are okay. We can also go for 0 comma 3, which will yield me output as 0. Yeah, so from here we can make an observation that if we choose n which is less than or equal to 3, we'll be getting maximum product as n minus 1. Okay, so this is a very important edge case which we'll be facing, as it is also one of the sample test cases where we have given n is equal to 2. So now let's move to the approach, how we have to approach this question. Okay, so yeah, so firstly we'll handle the base case which we have just discussed, that is if n is less than or equal to 3. If n is less than or equal to 3, we'll be simply returning n minus 1. Okay, so if this is not the case, we'll be initializing a dp array of size n plus 1, and after that we'll be filling the values for dp1 comma dp2 comma dp3, because we have already seen in the test case that we'll be filling these values as 1 comma 2 comma 3. dp1 will be assigned the value 1, dp2 will be assigned the value 2, and dp3 will be assigned the value 3. Okay, so now let's move to further. So let's initialize a for loop for performing this. For I equal to 1 to I less than equal to 3. What we'll just simply do, we'll do dp of I is equal to I. Okay, so after this we'll be using another for loop from basically from 4 to n, which will be given in the question for. Okay, so in the for loop will initialize another variable, let's say temp, which will be our current I, and then we'll use a for loop for j equal to 2 to I, and then we'll check temp would be equal to max of temp comma I into dp of I minus j. Yeah, so I'll let you know in a few minutes, like why we are using max function over here. Okay, so after this for loop ends, wait a second, let's put this in braces. Yeah, after the for loop ends, we'll just set dp of I would be equal to temp, and after this for loop we'll be just returning dp of n. So this is the pseudocode for the question, and if we try to see a test case, for example, where we are given n is equal to 10, let's say. Yeah, so these are the indexes. We here we have created a, like you can see, okay, wait a second. So here if you can see that we have created a DP array of size n plus, okay, we have created a DP size array of size n plus 1. So this will be providing us with 11 indexes starting from 0, 1, 0 up to 10. And for example, we will be having value for 0 in index 0 as 0 only, value for index 1 will be 1, similarly value of for index 2 will be 2, and value for index 3 will be 3. Okay, so up to this we have done. Now we'll be running the for this for int I equal to 4. Okay, let's change the font for this. Oh, it's not okay. So yeah, for we have in textbook, yeah, when I is equal to 4, yeah, when I will initialize the temp variable with I, then for I equal to 2 to 4, which is basically here 4. Yeah, so we'll be checking temp will be equal to max of temp, that is 4, or not a temp array, like, yeah, we'll use this temp 4. Okay, so here we'll be using a max function because let's say at some point, okay, so basically what temp function will do, it will what max function will do, for example, if here we are having I is equal to 4, so it will be, we'll be considering, also considering the value that is 1 into 4. Or, no, sorry, we'll not be considering 1 into 4, but like 0. Yeah. Oh, so the temp function will be considering, like, for example, using some other way we have achieved a value of 8, will be so we'll be just be continuing with the temp variable uh, to keep a track of maximum value, and we'll be doing I into dp of num I. Oh, here also, oh sorry, here it should be j. Yeah, dp I minus j. Okay, so this will be dating the value as I into dp I minus j. I, let's say I is 1 into dp of I is 4, sorry, I is 4, 4 minus 2, dp of 4 minus 2, that is basically second index, that is 1. Yeah, that is 1. So here temp will be equal to 4 only. If we, okay, if we move to the next iteration where j will be equal to 3, let's say this is for j equal to 2. If we move for j equal to 3, we'll be doing 4 into dp 4 minus 3, that is at dp1 we'll be having value as 1. 1. So temp variable will again be 4 only. Similarly, we'll be doing the j will be running up to this only. So now let's move to the next for I equal to 5. Yeah, let's say I is equal to 5 now, and now temp will be initialized to 5. Now let's run a for loop. J equal to 2 to 5. Yeah, so here what we'll be doing, we'll be updating temp for max value of 5 comma 5 into dp of 5 minus 2. dp of 5 minus 2, that is 3. So 5 minus 2 3, so that is 3. Yeah, dp 5 minus 2 and 2 3. So here temp is equal to 15. So here temp with 5 minus 2, that is 3 d, and dp3 will be having a, yeah, dp of I minus j, that temp would be equal to 15. Similarly, we'll be running for all the test cases. And now let's move to the coding window. So first, for the base case, if n is less than equal to 2, well, n is less than equal to 3, we'll be simply returning n minus 1, and then we'll be initializing a dp array and new int dp n plus 1 for int I equal to 1, I less than equal to 3, I plus plus dpi equal to I. So after this, then for int I equal to 4, y less than equal to n, I plus plus, then we'll be initializing a temp variable. Temp is equal to I for int j equal to 2, j less than I, j plus plus, then temp will be equal to math dot max temp comma I. Oh, sorry, I guess I've done a mistake here. It should be, yeah, here it should be basically j into dp of I minus j. So we'll be similarly we'll be updating here only. Yeah, so here it would, yeah, so the test case, yeah, that's why it was given here a wrong answer. So let's, yeah, do this j into dp of I minus j. Yeah, and here what we'll be doing after this for loop, we'll be just doing dp of I would be equal to 10, and at the end we'll be returning dp n, yeah, return dpn. So I guess this should work. Yeah, this works. So yeah, this is accepted. So this was the solution. Thank you.